The question is whether we'll rise to the occasion or let this rare chance slip through our fingers, like so many others, lost to doubt and delay. Yet even if we miss our shot to chase this cosmic wanderer, Comet 3I Atlas C2025K1 has already upended everything we thought we knew about cometary behaviour. And the deeper we look, the stranger it gets. Here's the part that simply shouldn't happen. When astronomers first spotted 3I Atlas on July 3, 2025, it was already blazing with activity, a bright, fuzzy coma and the first hint of a tail streaming behind it. Perfectly normal. Comets wake up when sunlight warms their crust, turning buried ices straight into gas that explodes outward. In early July, the comet was close enough to the sun for that process to kick in. Textbook stuff. But science never trusts first impressions, so researchers did what they always do. They went digging through the archives. They hunted for any telescope that might have accidentally snapped this patch of sky weeks or months earlier, and they struck gold. Make that frozen alien gold. NASA's TESS Planet Hunter had been staring at the exact same region for the entire month of May 2025. Designed to catch stars blinking as exoplanets cross their faces, TESS grabs a new full-frame image every 200 seconds. That relentless cadence builds a treasure trove of data. Hidden inside it were nearly 9,000 separate snapshots of 3I Atlas, while it was still parked way out past Jupiter, roughly 900 million kilometers from the Sun. At that distance, deep in the solar system's freezer, the comet should have been dead quiet. Solar heating's feeble out there, but it's still enough to crack open carbon dioxide ice and puff out a faint coma. That's exactly what every long-period comet has done since we started watching them. Distance? Check. Chemistry? Check. Later brightness measurements proved the comet was indeed ramping up during May. Its glow was climbing steadily. Everything lined up. Except one thing. When University of Maryland scientists stacked and processed those 9,000 TESS frames, they saw nothing. No coma. No haze. No tail. Just a sharp, star-like point of light drifting across the field, indistinguishable from a lifeless asteroid tumbling through the dark. They double-checked by overlaying the comet's brightness profile against known inert rocks. The match was uncanny. Whatever 3I Atlas was doing out beyond Jupiter, it wasn't behaving like any comet we've ever met. And that single, impossible silence in the data may be the biggest clue yet that this visitor isn't just rare. It's rewriting the rules of the outer solar system. Brightness profiles show how light fades from an object's core to its rim. Asteroids produce razor-sharp curves, pure reflections of hard rock. Comets draw soft, smudgy halos because their comas scatter sunlight every which way. The contrast is impossible to miss. When astronomers fed 3 Atlas into the same tests, the Ukikaisi curve snapped clean as any asteroids. No blur, no haze, no whisper of gas or dust. Every metric screamed inert boulder spinning through the void. Yet it wasn't inert. Starting mid-May, the total brightness began to climb, slowly, steadily. That climb is the calling card of cometary outburst, gas and dust jetting into space. The object was venting like a live comet while looking stone-cold dead. How can something erupt and still appear asleep? The team's explanation feels almost mischievous, as if the comet chose to play hide-and-seek. They argue 3 Atlas did grow a coma in May, but it stayed invisible for 2 linked reasons. First, the outflow was excruciatingly gentle, more seep than explosion. Picture thick syrup oozing instead of champagne popping. At that distance from the sun, with whatever exotic ices coat its crust, sublimation crept along at barely walking pace. Particles never drifted far. They hovered, forming a snug, heavy blanket that refused to bloom into the usual fluffy halo. Second, and this part still raises goosebumps, the size numbers refused to add up. Ground-based telescopes using TESS data pegged the diameter at about 6 kilometers. Then Hubble, with its eagle-eye resolution, peered straight at the nucleus and measured only 2.8 to 4.4 kilometers. Where did the missing girth vanish? It never vanished. TESS wasn't seeing bare rock, it was seeing rock in camouflage. A secret coma, so dense and clingy that it fused with the surface, inflating the apparent size while staying optically invisible. Think of trying to spot a black cat in a coal cellar at midnight. Same colour, same texture, same silhouette. The comb was there the whole time, wrapped like shrink wrap around the nucleus, turning the two into one seamless shape. This is the hidden coma phenomenon, a stealth shroud of gas and dust that hugs the core so tightly it masquerades as solid crust. Only the swelling brightness and the size mismatch betrayed the trick. The comet never lied. We just couldn't tell where the rock ended and the disguise began. It was a masterclass in cosmic sleight of hand, hiding in plain sight, wearing a mask so perfect even the sharpest telescopes mistook it for the real face. The implications reach far beyond this one enigmatic object. How many other comets have slipped through our fingers simply because their comas were too faint or too tightly bound to spot? How many asteroids in our swollen catalogues are actually dormant or barely breathing comets masquerading in broad daylight? The methods we've trusted for generations to separate asteroids from comets may have blindly ignored an entire grey zone population that refuses to pick a side. CYE 2024 S1 Atlas, or 3 Atlas, as the night shift astronomers now mutter over coffee, is rewriting the rulebook in real time. It's showing us that the cosmos loves a confidence trick. Even our sharpest telescopes can be conned. Even the neat little boxes we built for comet and asteroid are starting to look like suggestions rather than laws. This ghost drifted through the TESS satellite's stare for weeks, framed in thousands of pristine images, yet it kept its secret, wrapped in physics we hadn't bothered to question until yesterday. The hidden coma changes everything we thought we knew about its childhood. It means 3 Atlas was already sweating ice when it was still parked in the deep freeze past Jupiter, farther out than any comet has any business waking up. It means the engine driving its outgassing runs on a different fuel, ticks to a different clock, laughs at the textbooks. And it forces an uncomfortable whisper. If it could hide its breath when it was cold and distant, what else is it still hiding now that the sun is clawing at its skin? What invisible fireworks are popping off in that shroud that we lack the eyes or the imagination to see? There's something theatrical about the way 3 Atlas keeps peeling back masks. First it strolled in wearing the standard comet costume. Then it flashed that obscene carbon dioxide overdose that sent the models into therapy. Then it started puking water at distances that should have kept it locked in cryogenic sleep. And now, we learn it was play acting the whole time, showing us exactly what we expected to see until it decided the joke had gone on long enough. Some will shrug and call this just science doing science things, another Tuesday of paradigms limping home bruised. But the pattern is too clean to dismiss. Every time we pin a label on it, every time we crow that we finally bagged the weirdness, it flicks another card from its sleeve. It feels less like discovery and more like a duel, one where the comet keeps letting us land punches just to prove our gloves are padded. Researchers have already nicknamed it the ghost comet, and it's not done haunting us. Because on top of the stealth coma and every other middle finger to theory, the latest data show something that flat out violates the owner's manual of basic cometary physics, something that, by every equation we swear by, should be impossible. But that revelation deserves its own breath. First, we have to face the cold possibility that neither Europa Clipper nor Hera will ever get a close-up of this intruder's tail. There's still a narrow window, a desperate Hail Mary, the European Space Agency's JUICE spacecraft, already cruising toward Jupiter's icy moons, could be retargeted for a suicidal sprint. If the stars align and the fuel holds, it might just snatch the ghost comet's secrets before it flickers out into the dark forever. We'll be tracking Comet 3I Atlas all through November. ESA's JUICE spacecraft has 2 planned observation windows, November 2nd and November 25th, watching the interstellar visitor as it starts its long journey back into the dark between stars. JUICE won't plunge through the tail or scoop up samples. It can't touch the comet. But its instruments can still reach out across millions of kilometers, collecting spectra, measuring how the comet's glow fades as solar heat weakens. It's remote sensing, not a handshake. Like studying a campfire from the far side of a valley. Useful, limited, better than nothing. In deep space science, distant data is often the thin line between insight and blindness. Now shift to Hawaii, where the Keck 2 telescope has been staring at 3I Atlas through the clear Pacific nights. This is where unusual tips into deeply unsettling. The spectra reveal pure nickel vapor pouring off the surface in massive amounts. And here's the part that stops conversations cold. There is zero iron. nickel and iron are inseparable in the universe, born together in stellar explosions, welded into planet cores, mixed in every meteorite humanity has ever cradled. Finding nickel alone is like finding footprints with no traveller. It breaks a rule written across billions of years, yet the signal is crystal clear. Refined, industrial-grade nickel, no iron contamination. The spectral fingerprint matches exactly what spills from Earth's smelters when we run the MOND process. On Earth, the MOND process uses nickel carbonyl NiCO4, a volatile, poisonous gas formed under precise heat and pressure inside steel reactors. It's chemistry that belongs in factory pipes, not in a frozen iceberg from another star. University of Hawaii astronomers propose a natural mimic. Inside 3I Atlas, extreme CO and CO2 reservoirs, plus unknown reactions, might accidentally cook up nickel carbonyl. The compound flashes straight into vapour, dragging pure nickel atoms into space, while iron stays trapped in the rock. They're asking us to accept that blind cosmic chemistry, inside an alien visitor, randomly reinvented a patented human refinery technique. Maybe the universe just loves irony. Maybe when conditions line up, the same reactions ignite everywhere. On Earth in furnaces, out there in the dark on a wandering shard of another system. Or maybe, just maybe, something else is going on. Either way, every night the Keck Dome turns toward 3I Atlas, the data keep coming in, and the questions keep getting heavier. An object that cleverly conceals its coma while releasing water in places it has no business doing so. That craft's impossible anti-tails, unveiling its secrets in flawless order, as if directed by an unseen hand. One coincidence sparks curiosity. Two demand attention. But this many. At what threshold does coincidence crystallize into pattern? The nickel anomaly is hardly the lone chemical enigma. The comet's gas envelope remains profoundly strange. Approximately 87% carbon dioxide, 9% carbon monoxide, and scarcely any water vapour. Despite earlier detections of water outflow at 3 astronomical units, the proportions refuse to align. It behaves like several distinct bodies of divergent compositions superimposed in the same volume, showing different aspects depending on which telescope looks and at what precise moment. Then comes the anti-tail, visually the most arresting aberration, though its consequences are equally baffling as the chemistry. Typical comets display 2 tails. The dust tail arcs gracefully along the orbital track, trailing like a celestial wake. The ion tail juts directly away from the sun, shoved by solar wind and photon pressure. Yet under rare geometric alignments, some comets manifest an anti-tail. A sharp spur or blade that seems to aim sunward instead of fleeing it. Anti-tails are not paranormal. They are perspective tricks triggered when Earth's line of sight edges into the comet's orbital plane, and we view a broad sheet of debris face on. Particles actually fanning outwards suddenly appear to stab inward. Except 3I Atlas's anti-tail shatters every precedent. It is too vivid, too stubborn, too wrong. KEK observatory frames reveal a luminous lance accusing the sun, bright and unwavering, reappearing across disparate viewing geometries. This is no fleeting mirage. This is architecture. Picture a waterfall reversing upward against gravity. That is the spectacle we witness. Material that ought to stream sunward is instead sculpting a formation that thrusts back toward the star. Proposed mechanisms invoke exotic particle interactions, anomalous grain-sized spectra, undiscovered coupling forces, or perhaps the anti-tail is tethered to whatever furnace is forging that refined nickel vapour. Maybe a phenomenon is unfolding within this visitor that our physics lacks the vocabulary to name yet. A phenomenon that never arose in our corner of the galaxy because its birthplace was alien in the profoundest sense. Let us retreat and survey the entire tableau. An emissary from another star, 10 billion years ancient. Carbon-saturated chemistry unknown in our stellar backyard. It liberates water at distances where liquid should remain mythic. It masks its outbursts behind a phantom coma. It exhales pure nickel vapour, bearing the unmistakable fingerprint of manufacture. It fashions an anti-tail that mocks natural law. It discloses each riddle in immaculate succession, one revelation per act, as if adhering to a meticulous timetable. Taken singly, every paradox invites a plausible rationalization. Researchers can erect theories for each puzzle in solitude. Perhaps the water emerges from liberated ice grains. Perhaps the coma is dense sublimation. Perhaps the nickel is exotic chemistry. Perhaps the anti-tail is particle physics. Maybe. But when one object piles anomaly upon anomaly, the explanations begin to feel strained, like we're twisting reality to protect our theories instead of reshaping our theories to embrace reality. At what point does coincidence stretch beyond credibility? At what point do we pause the explanations and simply marvel? I'm not claiming Three-Eye Atlas is artificial. That's not what the data supports, and no serious scientist is saying it. Yet there remains a vast middle ground between ordinary natural objects we comprehend completely and deliberately engineered artifacts. There exists space for natural phenomena, born from conditions and processes we've never witnessed. Exotic physics and chemistry that only arise in specific stellar crucibles or in bodies of extreme age and composition. Three-Eye Atlas may be revealing what happens when material forged around a radically different star, a carbon-rich behemoth spawning chemical regimes impossible in our own system, drifts through interstellar space for billions of years, collecting cosmic ray scars and undergoing gradual internal metamorphosis, only to be abruptly jolted awake by our sun's radiation after eons of cryogenic slumber. This fusion of alien origin, unimaginable age, and sudden reactivation could produce behaviours that appear impossible simply because this precise cocktail of factors has never crossed our telescopes before. Here's what truly captivates. If you wanted to design something to seize humanity's collective gaze, to masquerade as natural yet stay eternally enigmatic, to invite exhaustive scrutiny while withholding simple answers, you'd craft something precisely like Three-Eye Atlas. The timing feels scripted. It arrived in the exact decade when we can detect interstellar visitors, yet still find them astonishing. 50 years earlier, we'd have missed it entirely. 50 years hence, such objects might be commonplace. Ho-hum. But in 2025, we sit in the perfect technological sweet spot, advanced enough to spot and study it, not advanced enough to decode it fully. The trajectory is suspiciously accommodating too. Oumuamua blasted through at warp speed, vanishing before we could blink. Yet Three-Eye Atlas lingers, moving slowly, remaining in prime viewing position for months, granting us generous time to probe. It's as though it's deliberately pacing itself, ensuring we catch every anomaly without spilling all secrets at once. And those anomalies arrive like perfectly timed chapters. Discovery, water outburst, chemical oddities, ancient age, hidden coma, industrial-grade nickel, impossible anti-tail. Each observing season delivers exactly one new riddle. Never too much, never dull, always just strange enough to command the world's attention. Is this sequence meaningful? Or is it simply how scientific discovery unfolds? Each new observation peeling back a layer only to reveal deeper complexities. The honest truth is, we don't know. We can't know yet. Our sample size is vanishingly small. We've closely studied just 3 interstellar objects, and every single one has been bizarre in its own way. We have no established baseline for what a normal interstellar visitor even looks like because the data simply isn't there. What we can say with absolute certainty is that Three-Eye Atlas marks a watershed moment in our ability to examine material born outside our solar system. Whether it's anomalies, point to exotic natural processes, or something far more provocative, the scientific payoff is enormous. Every spectrum, every image, every data point pushes the boundaries of what we believe is possible in the cosmos. The next few weeks are make or break. From now until early November, a series of golden opportunities will determine how much we ultimately learn. If Europa Clipper manages to sample the ion tail, if JUICE secures high-resolution spectra during its November flyby, if ground-based telescopes keep tracking the comet's rapid evolution, we'll assemble a dataset richer than anything collected from previous interstellar passers-by. The James Webb Space Telescope has already been watching Three-Eye Atlas. Webb's infrared vision slices through dust and gas that visible light telescopes can't penetrate, exposing the comet's heat signature and unveiling molecules that stay hidden from other instruments. Layer on Hubble's crisp, visible light portraits, spectroscopy from Keck and other world-class observatories, and possible direct spacecraft encounters, and you have a multi-wavelength, multi-platform campaign of unprecedented scale. This is 21st century astronomy in action. No lone telescope or spacecraft can tell the full story anymore. We need optical, infrared, ultraviolet. We need imaging, spectroscopy, direct sampling. We need ground stations talking to space telescopes, talking to deep space probes, all filling each other's blind spots. 3i Atlas is reaping the rewards of this symphony in a way Oumuamua never could. When the first interstellar object streaked through in 2017, we were flat-footed. Telescopes weren't primed, protocols didn't exist, and it vanished before we could mount a proper response. Borisov in 2019 gave us more warning, but it was still a frantic scramble to line up observing time and coordinate globally. With 3i Atlas, the community was ready. Early warning networks flagged it months out. International campaigns spun up within days. Flagship telescopes carved out blocks of time. Mission teams ran trajectory checks to see if their spacecraft could contribute. This is the hard-won muscle memory from the first two visitors. How to mobilize fast, how to share data seamlessly, how to squeeze every drop of science from a once-in-a-lifetime event. The flood of data now pouring in will occupy researchers for years. Papers dissecting 3i Atlas's chemistry, trajectory, and birthplace will keep hitting journals long after the comet itself has dwindled to a faint smudge. Grad students will mine this treasure trove for theses. Fresh theories on comet formation and interstellar chemistry will be born. Our picture of how diverse planetary systems can be will grow sharper and stranger. And when the next interstellar wanderer arrives, we'll be even better prepared, because 3i Atlas just raised the bar for what's possible. But beyond the technical and scientific breakthroughs, something far deeper is unfolding. These interstellar wanderers are reshaping our sense of belonging in the galaxy. They're turning the cosmos into a living, interconnected web, vibrant, restless, brimming with unforeseen encounters. For billions of years, our solar system drifted in splendid isolation. Matter born here, stayed here, evolved here, recycled here. We traded a few fragments with neighbouring stars back when the sun was still in its chaotic stellar nursery. Yet for nearly all of cosmic history, we were a sealed realm, an island of dust and gas hurtling alone through the void. That solitude is crumbling. We now know that relics from alien stars slip through our neighbourhood on a regular basis. Not often enough to be routine, but frequently enough to catch with today's instruments. Every few years, if we keep vigilant, something arrives from the outside, bearing secrets from stellar cradles we may never directly explore. This is a new era of discovery. We can't dispatch probes to distant suns, not with present rockets, not within a single human lifetime. The gulfs are too immense, the power demands too crushing. But other stars are dispatching probes to us, unintentionally, through the wild turbulence of planetary birth and death. Every few years, a comet or asteroid is flung from its parent system, cast into the interstellar night, and an infinitesimal fraction of those exiles eventually crosses our path. These are sample return missions we never funded. They're deep space scouts that needed no engines, no navigation, no decades of design. They are unsolicited presents from the Milky Way, drifting in on their own momentum, asking only that we look up, study them, and learn before they vanish forever. 3i Atlas will exit our domain before this year ends. It will glide past Mars, then Jupiter, Saturn, Neptune, even distant Pluto, accelerating outward until our mightiest telescopes lose its fading glimmer. The sun's grasp will loosen, and it will rejoin the interstellar current, free to roam the galaxy, perhaps brushing another star's domain billions of years hence. Yet for these fleeting months of 2025, it belonged to us. It came close enough to resolve, active enough to measure, bizarre enough to mesmerize. And whether the planned spacecraft succeed in tasting its tail, whether every anomaly eventually yields to explanation, it has already achieved something monumental. It has proven that the universe is wildly more inventive than our models ever predicted. It has shown that natural forces can craft outcomes that feel deliberate, that appear engineered, simply because they arise in environments we've never sampled. It has shattered our tidy taxonomies, the sharp lines we drew between asteroids and comets, between dormant and dynamic, between known and unknowable, revealing them as fragile scaffolds that reality keeps toppling. The nickel signal alone, ensures 3i Atlas will spark arguments and papers for decades. Some scientists will chase exotic chemistry theories, building ever more detailed simulations. Some will chase the enigma of how nickel carbonyl could ever form inside a carbonaceous comet. Others will hunt for alternative pathways, different chemistries, different histories, that could still produce that unmistakable elemental fingerprint. And a few, in hushed sidebar chats at conferences, will dare to ask whether we're staring at something our current paradigms simply can't contain. This is science at its best. Mystery is the engine. Questions without tidy answers force us to sharpen our tools, rethink our assumptions, and build instruments we didn't know we needed. If 3i Atlas had been a textbook interloper, behaving exactly as every model predicted, it would have been neat, publishable, forgettable. The glitches, the outliers, the stubborn refusal to fit, those are the sparks that ignite revolutions. There's also a human pulse beneath the data. Interstellar objects seize the public imagination in ways few discoveries can. People don't need a PhD to feel the weight of something born around another star passing through our sky. It's a postcard from the deep cosmos, tangible, intimate, undeniable. That connection matters. It reminds taxpayers why telescopes and spacecraft are worth every penny. It proves we still live in an age of genuine firsts, that the universe hasn't run out of surprises, that science isn't just dotting I's on old pages, but ripping open new chapters. When headlines scream that 3i Atlas is gushing water far beyond the snowline, or belching industrial-grade nickel vapours, wonder ripples outward. In a time when research budgets are perpetually on the chopping block, that shared awe is political capital. It's the difference between a line-item expense and a civilizational priority. So what comes next? Right now we watch and wait. Fingers crossed that Europa Clippers team can steal a glimpse during the tail-crossing window. November brings Juice's turn. Ground-based scopes keep vigil as the comet dims. Every new spectrum could carry another jolt. Longer term, we're getting ready for the next stranger. Vera Rubin Observatory flips the switch soon, scanning the whole visible sky every few nights, catching faint wanderers years earlier than today's surveys. Rapid response probes are moving from drawing board to hardware. ESA's Comet Interceptor will loiter at L2 until the perfect target appears, then sprint to meet it. JAXA has parallel plans. Next time an interstellar comet knocks, we won't just wave from the porch. We'll open the door and invite it in for coffee. Up close, under alien sunlight, finally face to face, with matter forged around another star, private enterprises are now investigating whether compact, rapid response probes could be engineered and deployed swiftly enough to intercept interstellar objects while they remain within the inner solar system. The required technology is progressing at breakneck, speed fueled by extreme miniaturization, revolutionary propulsion systems and, most crucially, the confirmed existence of these elusive targets waiting to be examined. Naturally, Atlas will not be the final enigma arriving from beyond our star. It is merely the newest installment in what is evolving into a continuous saga of revelation and awe. Every interstellar interloper delivers fresh puzzles, fresh assaults on our paradigms, fresh windows into the staggering variety of planetary systems strewn across the Milky Way. And perhaps, just perhaps, one future visitor will finally deliver answers more bizarre than anything we are presently equipped to contemplate. Not because the universe is playing tricks, but because it is vaster, more intricate and brimming with potentialities that dwarf our existing models. For now, 3 Atlas continues its silent exodus, ferrying its enigmas into the abyss beyond our worlds. Some of those enigmas we have deciphered. Others lie dormant in datasets we have yet to exhaust. And a few perhaps will remain forever beyond our grasp, at least with today's instruments and theories. But that is the essence of exploration. Each solution births new riddles. Each mystery unravelled unveils deeper mysteries lurking farther out. The comet originated around another star, wandered for billions of years, grazed our tiny domain for a fleeting handful of months, and will shortly vanish eternally into the interstellar gulf. It was here. We detected it. We scrutinised it. We marvelled at it. The phantom comet hailed from another star, journeyed for roughly 10 billion years, brushed through our modest patch of space for a few short months, and will soon dissolve forever into the interstellar void. It manifested concealed comas and inconceivable chemistry. It vented purified nickel like an orbital refinery. It sprouted anti-tales that defy known physics. It unveiled anomalies in flawless succession, as though executing some cryptic program. Was it natural? Almost certainly. The universe can achieve astonishing feats when circumstances converge in ways we have never witnessed. Exotic reactions in carbon-saturated realms, primordial mechanisms we have yet to fathom. Physics still awaiting discovery. Yet another possibility lingers, one that cautious researchers refuse to utter aloud, though it murmurs through the measurements. What if certain riddles are designed to resist immediate resolution? What if certain intruders exist to provoke doubt, to ignite curiosity, to force us to confront the immensity of our ignorance? We possess the raw data, we hold the observations, we command the facts. What we lack are all the explanations, and perhaps that is precisely the intention. The universe, it appears, still has volumes to teach us, and 3 Atlas, with its factory-like emissions, impeccable timing, and impossible conduct, delivered the profoundest lesson of all. We are not nearly as advanced as we believe. The cosmos is far stranger than we suppose, and the next intruder may prove stranger still. It is out there at this very moment, receding into the gloom beyond our planets, bearing its secrets along. Some secrets we have unlocked, others we have merely glimpsed, and some perhaps we were never intended to comprehend completely. Not yet.